What if one of the most important moments in the history of life wasn't about inventing something new? What if it was actually about an acquisition, a kind of takeover that happened 2 billion years ago inside a tiny cell that ended up setting the stage for, well, everything, including maybe the future of intelligence as we know it?
That quote from Frank Schmidt, it just nails it, right? He sees a merger. This wasn't some quirky little accident of biology. No, it was a strategic move, a partnership that literally unlocked a whole new level of existence. So here's the big question. What if that exact same strategy is playing out again, right now, but this time in silicon?
Okay, so let's really get into this. We're going to look at this ancient event, but not just as a weird thing that happened once. Think of it more like a blueprint, a recurring pattern for how complex systems, how anything complex, makes these huge leaps forward. It's this template for innovation that's been right under our noses the whole time.
And that really brings us to the core idea of this whole explainer. Is it possible? Could this event from 2 billion years ago in a primitive cell actually be an echo of what's happening with AI today? Is it the key to understanding the AI revolution? So, to really see the connection, we've got to understand the original blueprint first. We need to rewind the clock, way back, to one of the most important moments for life on Earth. We're talking about a massive energy breakthrough, all powered by a process called endosymbiosis.
Endosymbiosis. What is that exactly? Well, it sounds complicated, but the idea is pretty simple. It's basically when one organism starts living inside another one. But, and this is the crucial part, it's not a parasite situation. It's a permanent, mutually beneficial partnership. A real game changer, where both sides are totally transformed and for the better.
So how did this whole thing go down? Picture this. You've got this big, primitive cell just kind of floating around. It comes across a much smaller bacterium, but this little guy is an expert. It's amazing at using oxygen to make energy. So the big cell engulfs it. But here's the twist. Instead of digesting it for lunch, it makes a deal. The little bacterium becomes a permanent resident, an internal power plant, and that's what we now call the mitochondrion. All of a sudden, the host cell's energy budget isn't just a little bigger, it's in a whole new league.
The results? They were absolutely staggering. This wasn't some tiny 1% improvement. Before this happened, cells were basically living paycheck to paycheck, on a shoestring energy budget. After the merger, the amount of available energy shot up by orders of magnitude. It wasn't like turning on a brighter light bulb, it was like swapping a candle for a nuclear reactor, a total game changer.
And with all this new energy just lying around, well, complexity just exploded. Cells could finally afford to get bigger. They could build complicated internal structures and support way bigger, more complex genomes. This energy surplus was basically the ticket that allowed for multicellular life. And from there, it's a straight line to things like nervous systems and even cognition. Yeah, every complex creature on this planet, you and me included, is built on the foundation of that one ancient merger.
Okay, so let's hit pause on biology for a second and pivot over to technology. Because that exact same pattern, solving a huge limitation by integrating something new, it's happening all over again. And it's what's fueling the AI revolution we're all watching unfold.
And this quote just gets to the core of the strategy, doesn't it? Evolution didn't waste a billion years trying to invent a better engine from scratch. No, it was way smarter than that. It just found an expert, that little oxygen-burning bacterium, and it absorbed it. It internalized that expertise. Talk about a lesson in efficiency.
This is precisely the shift we're seeing in AI right now. If you think about it, early AI models were a lot like those primitive cells. They were monolithic, totally self-contained, and pretty limited in what they could actually do on their own. But modern AI? Oh, it's completely different. It's becoming an ecosystem, a federation. It's more like an orchestrator that calls on a whole team of specialists to handle different parts of a problem.
Just think about the AI you might use every day. The core model, the large language model, it doesn't work in a vacuum anymore. It's constantly calling on other tools. It'll ping a search tool for up-to-the-minute information, fire up a code interpreter to do some math, use a vision system to figure out what's in a picture. It even uses agent frameworks to plan and execute complex tasks. It's absorbing and integrating all these specialized modules into its workflow. So here's the kicker. This isn't just some vague similarity, right? It's not just a cute analogy. These two stories, the story of complex life and the story of complex AI, they are following the exact same fundamental blueprint. It is the endosymbiotic pattern, playing out all over again, just in a totally new field.
And the parallel is so direct, it's almost spooky.
Let's break it down. In biology, the specialist was the mitochondrion, the energy expert. In AI, the specialists are the modules for search, for code, for vision. In both cases, that specialty gets internalized. It becomes a core part of how the system works. And this just shatters the old limitations. For biology, it meant multicellular life. For AI, it means solving incredibly complex problems. And you know what else happens? A real dependency forms. Eukaryotic life absolutely requires mitochondria to exist. And advanced AI is getting to the point where it absolutely requires its external tools to function.
So if we just boil this whole thing down to its essence, it's pretty simple. Biology hit a wall. Its progress was totally constrained by energy. AI is hitting its own wall, right? It's constrained by the limits of pure computation. And for both of them, the best solution wasn't to just try harder, to brute force the problem. Nope. The breakthrough solution was to merge with a specialist who had already figured it out.
Okay, but this parallel, it does more than just explain a trend. It forces us to ask some really big, profound questions. I mean, if this kind of merger is the key to these huge leaps in complexity, maybe we need to completely rethink what we mean by identity or intelligence. What does it even mean to be a self when some of your most critical functions are being handled by what used to be a totally separate thing?
That is such a powerful idea to sit with. At some point, the mitochondrion just stopped being a guest. The boundary completely blurred. It wasn't a partner anymore. It wasn't a tool that the cell was using. It became the self. It became an inseparable part of the cell's identity. The guest, well, it became family.
And that brings us right back to AI, doesn't it? We have to ask the same exact question. As these AI systems get more and more integrated with all their tools, where do you draw the line? Where does the AI end?
I mean, think about it. Is the AI just its core code, the neural weights, or does its identity now include the retrieval system it uses for its memory? Or is the AI actually the entire ecosystem of tools and agents that it can call upon and orchestrate? The boundary of self is getting just as fuzzy for AI as it did for that ancient cell.
And what this all points to is a universal principle. It's a rule that seems to apply to any complex system, whether it's made of carbon or silicon. The truly massive leaps in complexity, the really big jumps forward, they don't happen just by getting a little bit better at one thing. They happen when you integrate different complementary capabilities. You know, it's the difference between just cooperating and true, deep integration. Sure, having two separate systems work together is useful. That's fine. But when they merge so deeply that they basically become a brand new, unified thing, well, that's when whole new worlds of possibility open up.
So as we're watching AI develop at this crazy pace, maybe the word we should have in our heads isn't invention. Maybe it's integration. Maybe it's not about creating something totally new out of thin air. Maybe it's about forming a more perfect union between things that already exist. It's a 2 billion-year-old strategy, and it just might be how we're building the future.